Hey guys, I am currently elbow deep in the Sencore SM152 Sweep Marker generator. I picked this up some months ago, and I've teased it a few times, mentioning I'd like to use it for an alignment video. Well, welcome to the perils of vintage test equipment. Doesn't work right. The output level is really weak, and it does not vary like it should with the variable output level. Information on this unit online is scarce, but luckily, somebody on the Antique Radio Forum posted 4 pages of info, schematic and parts list. So, I took a quick look at it initially last night and thought, this is a little above and beyond anything I want to deal with. But a day later, I thought I'd give it another whack. In particular, I'd focus on this output unit, and I found a resistor. It's way out of spec, a 100 ohm resistor. It's measuring nearly 1K, so about 10 times what it should be. And this little board here is the automatic leveling controller board, the ALC board. And that's something that your cheapo sweep generators won't have. Your older ones, more primitive tube-based ones, just because, well, tubes are big and you can't pack that many in there. So what does the ALC do, automatic level control? Well, nothing's perfect in the electronics world. So without this unit, the output level can and likely will vary with frequency. You don't want that. You want the output level to be very consistent as you scan across frequencies, because normally you put this into a device and you want to check its frequency response. So you need to have a constant level in for all frequencies to get a valid output. That's what this little board does. It samples the output level and feeds its feedback loop. So if the output level droops, this should boost an internal amplifier to keep the output level constant. So if this isn't working right, I hope that's it. I spot checked the other resistors on this board and they seem to be okay, but of course we have other devices. We have a whole bunch of transistors in this thing. And, boy, this this thing is a trip. Now I just have a schematic. As you can see, there are a ton of adjustments. All these coils, all these resistors are variable resistors, and they're all glued, they're all factory calibrated. I don't have the calibration instructions, so I have no hope, if I had to really dig into this, of adjusting any of those, not with the info I have on hand. It had been worked on previously at some point. It looks like this rectifier and this cap have been replaced. That's the power supply. To check the power supply, it's pretty much dead on. Should be 24 volts at about 25 for the main supply for this device. The real action takes place in here as far as the sweeping action goes. So it's the seal box. Generally, these sweep generators, RF generators, they're not that serviceable. So if you really want to get into this, I suggest you buy one from a reputable seller that says it's working, and not just powers up, but is working. Or buy something newer, helps too. Anyways, I will place that resistor. Check anything else on here. If one of those, I think their FETs is bad. I don't have any replacements, and they're a matched pair, which does not help matters. So if that doesn't do it, I have plenty of other devices I can use, but that will sideline this particular device for now. But I will show you what it can do when it is working, whether or not this repair is successful or not. I'll show you what this device can do and why it's pretty nifty. Geez, I gotta say, if I wanted to really use this as my go-to device on the workbench every day and do accurate alignments, this would really need an overhaul because I'm spot checking resistors and a lot of them are out of spec. For example, this is a range switch, and it's a sort of a stepped attenuator. So we have all these resistor values over and over. These should all be 62 ohms. These should all be 15. This guy's measuring 90. So that's going to throw off the decade division on that. More importantly, back to this board, I replaced the 100 ohm resistor. It was measuring about 1K. Nearby is a 22K resistor. It's measuring almost 1 meg. So that's got to go. So if just on this one little spot checking of a dozen resistors, I found 2 that were horribly bad and 1 that's pretty bad and a few others that are slightly out of spec. There could be loads of other problems, but I'm not going to go through all that right now. Let's just see if that did the trick. Now, one good thing is that some of the accuracy of this is crystal controlled. That's not going to be thrown off resistors by resistors being out of spec. So I think this may still be useful as is. Well, I'm not one much for servicing test equipment, especially with such scant service info, but that had a significant effect. Now I have actual output I can see. Previously, there was just barely anything. It looked more like noise than an actual signal, and the frequency varies with the scale. Now this is in continuous mode or fixed frequency mode. I am not in sweep mode. So let's go through the various ranges. Now it is sweeping, just the chroma range, but that's why you can tell when something is sweeping because it looks smeared, because the frequency is changing. There's a much lower range. So now we're in the, you can go all the way down to 10.7 or so to do FM radios, and then older IFs and then newer IFs. So that's very cool. And I should vary the sweep. I'm changing the sweep width, so as I sweep more intensely, it gets crazy. Wow, that is a really trippy effect on the scope. I'm using the venerable 465, and I have this at the maximum range. I'm putting out, around 20-30 megahertz. Let's see if I go variable. Can I stretch that now? I guess I could magnify it, but then it's going to be even harder to see, maybe. There's something. Sort of like a zoom effect, anyways. What else we got? That's the higher IF range. Whoa. Oh, no. Oh, now I'm into VHF and now UHF, so no, we're not going to be seeing that. But let's get back to this. Cool. Cool. I think this thing may very well be working well enough now that I can actually use it. Awesome. Now I'll show you what you can actually do with it. Alright, now that it seems to be working, let's talk about what is it and why might you want it. Well, as it says, it's a sweep and marker generator. What does that mean? It means it can sweep frequencies. And that is just like taking a good old-fashioned RF generator like this one we have in the background and having an internal motor or some device do this. That's all it comes down to. That's what a sweep generator is. Instead of you having to turn the knob, it turns the knob. And it turns the knob in a very precise, controlled manner. So you get a linear scan of frequencies. And then you feed that into a device, and you take the output of the device, feed it back into this, it does some magic, and you take the output of this and you go to your scope. Vertical and your scope horizontal. Now, one thing that I see people confused about all the time with using devices like this is they don't know how to hook up their scope. Your scope needs to be in XY mode, not the normal mode where you have the time base and Because what I see guys doing all the time is what I showed you. They're looking at that. They're looking at the actual output of this. They're looking at sine waves. You don't want voltage versus time. You want voltage versus frequency. You need to have a scope that can do XY mode, and this goes into your X and this goes into your Y. And the output of this goes to whatever you're working on, your TV in this case. And then at some point, you're going to hook up a probe into your TV, typically after the detector, and it feeds back into this. That's what the detector in is for. Now the magic that this will do is add these markers, and they have push buttons for the markers. So your resulting display will be like one of these, where this is your scope display, and this is your horizontal, that's your vertical, and you'll see a lump. The markers will put a little squiggle at certain key frequencies on here. These are frequencies that are typically very important for TVs, having to do with the video carrier, the sound carrier, the color burst, and so on. And the goal is to get it looking like that, or as is indicated in the service info, they will very typically give you something that looks like this. And your mission is to twiddle variable inductors, variable capacitors, hook up this device, and get that on your scope screen with little squiggles at those numbers. This device will let you do that, or help you to do that. Now, what's especially nice about this is the IF frequencies for TV changed over time, just like with radios. You look at really early AM radios, they have an IF frequency of maybe 175. Then later it became 455. With TVs, the earlier IF was centered around 22 megahertz. Later, not much later, starting, well, some sets earlier than others, or some brands earlier than others, but let's say around 1950, 51, 52, they started going to 44. By the late 50s, everybody was at 44. So most sweep generators you'll find, most vintage sweep generators will only do the 44 megahertz, like your B&K 415, or there's a Sencore, a newer one, a Speed Aligner. I forget the model number, but it only does the 44. This will do the older ones. However, you don't get markers for the older, which kind of stinks, but at least they can sweep it. And that's trouble I have with my newer devices too, but they don't go down that low in frequency. So let's go through the various modes left to right. And, oh yeah, this is a really neat feature. As you change the mode, this entire display changes up here. And it's backlit too, which is kind of nifty. So, and they actually tell you, when you put it in this chroma mode, they tell you what you get out and what you might want to do with it. So this, in particular, this chroma mode, is for color TVs. It's for helping you set up the chroma bandpass filter to pick out the signals that you need to focus on for color circuits. Not something I deal with much, which is why I'm stumbling over the words a little bit. That's a little outside my realm of knowledge, because mostly I work with black and white, but that's what that's for. This guy is a fixed RF generator, but it can only go from 39 to 48, which is not so great. That's the one issue I've seen with this that would make me hesitate. This can't do everything I would need to do. For the older 22 megahertz IF sets, very often you're going to need some fixed frequencies centered around 22 megahertz, and you need to peak coils. You can't do it with this device. But at least on the sweep range, you can sweep from 10 to 55. So if I was to put this around 22, in fact they have a key frequency, they have three key frequencies, 10.7, 25.75, 45.75. Those are key frequencies for FM sound, the older TV IF and the newer TV IF. I'll explain in a moment how you can get around the limitation of not having a fixed frequency in this range. But so what does this mean when you're in this mode? If I put this on 20 and look at this on a scope, you're going to see the waveform, what we showed earlier, where it was wiggling. It's scanning, depending on what your sweep width is. It goes from 0.3 megahertz up to a little over 10. Let's just say it's 10. What that means is it'll go between 15 and 25 megahertz. It'll sweep this. It's like doing this. Imagine if you were just sitting here going back and forth. You hooked up a little motor on a cam and it just did this. That's what it's doing, but it's doing it for you so you don't have to tire out your wrist. And when you're aligning a TV, you'll have instructions. Don't even think about aligning a TV without having detailed instructions. It'll tell you, center your sweep generator on 25 megahertz and do a 10 megahertz sweep width. It'll tell you what how to set these controls. So that you would use for doing your video IF. The higher, 50 to 120, you can see right here, it's channels. This would be for your tuner. Channel 2, 3, 4, 5, 6, and then FM radio. So you can use this device to align FM radios as well. If we get into this, we get the higher channels, VHF channel 7 through 13, and it even does UHF. So, it's almost perfect. Almost. Where it can do FM sound, the older, the newer, the IF, and so on and so on. If it just had more capabilities for the older IF. But I can understand by the time this device came out, which I think is 70s or 60s, it was laughably obsolete. So the fact they supported it all is a very, very nice thing. Now these markers are for the video, the 44 megahertz video IF. Pardon me. Here's a closer look at the markers. The bottom numbers here, that'd be for your 44 megahertz video IF, where you're trying to get this curve. Above it, some of these do double duty in the chroma mode for doing your color burst bandpass filter. These are for your tuner. You have several TV channels, and then 10.7 megahertz sound on the far right. Now, one thing that's odd, I just realized is also missing from this, is TV sound isn't 10.7 megahertz, it's 4.5. There's no mode on this specific to 4.5 megahertz. Typically, you don't sweep that, but you'd certainly want to have a fixed 4.5. All my test pattern generators can do it, so it's not a big deal. I have other devices that can use it, so I have yet, it probably doesn't exist. It's probably a unicorn, the one device that would do anything and everything you'd ever want to do. Specific to TVs anyways, yes, there are some very fancy, high-end HP sweep generators that can do everything, but you need to set it up and program it. It doesn't have specific TV modes built in, I think. But given the availability of this, they show up on eBay now and then. I probably got this for $50. Came with all the probes, essentially new in box. It's in a little bit of use. And yeah, I had to do some repairs, and there's probably some other stuff that's off a little bit. Assuming it's working, it's a pretty darn versatile device. I'm going to wrap up this video with actually hooking this up to a TV chassis, and let's see if we can get it to do something. Now, when it comes to vintage equipment, specifically, especially stuff like this, you really, really want to get the probes. For one thing, these are mostly RCA jacks, not BNC, which is kind of annoying. The external marker in and this RF output are Type F connectors. Oh yeah, I should have mentioned this, external marker in. If none of these markers do what you want, you can feed an external marker in. That's what I was saying about, okay, we can't do a fixed frequency in the 20 megahertz range, but I could sweep in this range and put an external marker in around 20, 21, 22, 23 megahertz. And I could kind of muddle my way through with that. that'll make more sense later in the series when I talk about using these things more. But luckily I have all these probes. Came with a whole bunch of RCA to just 2 alligator clips, so I can hook it all up with that. I'm going to use it with a Tektronix 465 scope in XY mode and a Predicta 9L37 chassis, which does use the 44 megahertz IF. Okay, let's see if I can briefly explain what the heck is going on here. So, RF output from the 152 is going over and around to this, which is a tube shield that I put masking tape around the base of, and it's just going over the mixer tube. That's what the alignment instructions call for, and that's actually a fairly common way to do it. You don't hook up your RF output to the antenna input or anywhere else. It actually just goes on a piece of metal over a tube that will couple the signal into the set. The detector probe is going to the output of the IF after the detector tube. And then the vertical and horizontal are simply going to the vertical and horizontal inputs on my scope in XY mode, and we get this display. That is the frequency response of this amplifier. So on the x-axis, frequency. Y-axis, amplitude. Now I have no idea what any of these frequencies are, other than I know it's centered around 45. And if I take this knob and move it, you can see it's going around. Now here's something kind of odd. When I increase the frequency, it's going off to the left. But think about it. I'm changing the center frequency. So say right now the center frequency is 45. Now it's 46, 47, 48, 49, 50. So my response is going off the screen that way. Now if I want some clue what these frequencies are, I can start pushing these buttons in. Don't see them, right? Well, there are controls for how they appear. Right now I have minimum. If I start increasing them, start seeing our little blips, and you can make them even more prominent or even more. It's probably a good compromise right there. Let me zoom in a little bit on that. So that is supposed to look like that, and it does not. Now to do it, you go through these instructions. Now these instructions, as is very typical of TVs of this era, the instructions don't call for a sweep generator. They call for a fixed RF generator. For example, they say inject 42.7 megacycles and peak 1 coil. Inject 45.75 megahertz and peak a coil. Inject 43.85 megahertz and peak a coil. Most servicemen back then, most shops didn't have all this fancy gear, but they would always have an RF generator and a VTVM. So most instructions focus on that. And if they have anything about sweep, it's just the final line where they say, well, if you have one, hook it up and see if the overall response is correct after you went through and used the instructions for a fixed non-sweeping generator. However, you can do it just totally visually going by this, and I'll adjust one of the coils, and well, you see it has a dramatic effect. Just doing it like this and randomly going back and forth between the coils is a really difficult way to do it. I highly recommend you get yourself a fixed generator and go through the instructions as explained, rather than just thinking, oh, I'll just dive in and do it visually like this. Now, luckily, this has a fixed mode. So if I go over to here's the fixed mode. Unfortunately, when you're in fixed frequency mode, you don't see anything. You have to change your scope and actually use it as a scope normally would be, or hook up a VTVM. You can't. It's not sweeping anymore. It's a fixed frequency. So you need to get a good understanding of how this stuff works and what you're actually trying to do. which is what I'm going to be talking about in the other installments in this series. So I'm going to do some videos on equipment such as this, and just give you a feel for what the equipment can do and how it does it and how it hooks up. And then I want to talk about theory, and then I want to talk about actually going through and doing it for real and following all the instructions as described. And I'll show you how to interpret the instructions and decide what equipment you're going to need and get it up on the workbench. Yeah, it's pretty cool that the output level works now. Here's another quirk. I skipped this stuff. I'm supposed to disable the AGC. I haven't. So it's kind of funny. You can change this knob and the output doesn't exactly change with it. That's because it's fighting me. It's the amplifier is modifying its gain as I've modified the input level. It's kind of funny to fight with. But yeah, hey, that was a really easy repair, and I'm very glad, because it was a rather intimidating looking device on the inside. As I said, these show up fairly regularly. I wouldn't spend more than $100 for one unless it's pristine and guaranteed to work. It doesn't do everything, and as you've seen, it's full of carbon comp resistors, and you may need to do a little work on it. But it does do a lot of stuff, and it's compact, it's solid state. You just turn it on and away you go. So it's kind of a neat thing. That's going to be it for now. I'll be looking for more installments in this series coming up. Thanks for watching.